Okay, so if you think you know a lot about powers and exponents, well, then you should be able to easily figure out the answer to this problem without using a calculator. Let's take a look at the problem. We have 8 to the 2/3 power times 9 to the 1/2 power. So we have a product of two numbers, and the product is equal to one of these. We do have a multiple choice question. And let's take a look at our answers here. So A is 2, B is 2/3, C is 8, and D is 12. All right, so once again, no calculators, but if you could figure this out, go ahead and put your answer into the comment section. I'll share the correct answer in just 1 second. Then, of course, I'm going to walk through step by step how to solve this problem without using a calculator. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, well, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. All right, so once again, we have a product of two powers. So we have 8 and 2/3, and we're multiplying it by 9 and 1/2. Let's go ahead and take a look at the correct answer. The correct answer here is D, 12. Now, if you got this right, you definitely get a happy face, an A plus, and 100%, and a certificate of excellence because indeed you appear to be a certified professional expert in the area of working with powers and exponents, which means you know a thing or two about the properties of powers and exponents. And in this particular case, our exponents, which is this part of the power, are rational numbers. So we're talking about something here called rational exponents. So if you're saying, hey, Mr. YouTube Math Man, I'm a little bit lost, what should I do? Well, stick around for a couple minutes. I'm going to teach you a thing or two. But if you, let's say you are a math student and you encounter this on a test and you're like, well, I have no idea what to do. Well, never, ever, ever leave a question blank on a math test, especially a multiple choice question. So always take a guess, and I'll be the first one to tell you, yes, yes, guess. And don't feel bad when you take a math test or a quiz or an exam. The object of that exam or test, from your angle, the student or the test taker's angle, is to get as many points as possible. Now, of course, the teacher is trying to determine what math you, understand, how good is your math skills. But your object is to just really get as many points as you possibly can, right? So here you have a 1 out of 4 chance. So guess. The only time you shouldn't guess on a math question is if you're going to get penalized for a wrong answer. And that could be the case on some exams like the SAT or ACT. So you might be saying, well, I don't know, our exponents here are fractions, so maybe our answer is going to be some sort of fraction. So you might select B, which is a fantastic guess. Unfortunately, it is incorrect. So you might be saying, all right, Mr. YouTube Math Man, let's just go ahead and figure out how to do this problem. And I think that's what we should do. So to really kind of improve your odds of doing well on any math exam, it's always best to actually know the math. So let's go ahead and get into that right now. But one more time, let's observe that we are dealing with a problem here that has fractions as the exponents. So if we have something like 2 to the third power, the 3 is the exponent part of that power, the 2 is the base, the entire thing here is an exponent. So hopefully, if I give you a problem like 2 to the third times 2 to the fourth, you can understand, how to solve this problem without using a calculator. Now, let's take a look at another problem, and hopefully we'll kind of just gauge where you're at right now with powers and exponents. If I gave you 2 to the third times 5 squared, which one of these problems can we do pretty easily without a calculator? Well, actually, you could do both without a calculator. In other words, we can literally go in and just say, all right, 2 to the third power is what? This means 2 times 2 times 2, or 8. And then 2 to the fourth means what? Well, that's 16. So here we have 8 times 16. We could just get this number. But what we're talking about here is really trying to use the properties of powers and exponents. So when we're multiplying two powers where the bases are the same, what we can do is simply add the exponents. So the answer here is 2 to the 3 plus 4, or 2 to the 7th. Now, in this example right here, we cannot use the powers of properties and exponents because the bases are not the same. Okay, so basically we're just left with this expression right here, but we could certainly figure out the actual numeric value because 2 to the third is 8 and 5 squared is 25. So we could do that number crunching and get our actual value here. But in this particular problem, what we want to do is use the powers, or excuse me, the properties of powers and exponents to figure out the right answer, because you might be saying, well, 8 to the 2/3, what is the actual numeric value for this number? Or even 9 to the 1/2? Well, we need to know a thing or two about rational exponents. So let's go and get into that right now. So again, we are talking about the product of two powers here where the exponents are rational. Now, I keep saying rational exponents. What does that mean? Well, remember, a number that can be expressed as a fraction of integers like 2/3 or 1/2, these are rational numbers, right? Even like 0.25, that's equivalent to 1/4. So rational numbers are numbers that we can express as fractions where the numerator and the denominator are integers. In other words, not just any fraction. So if we had the square root of 3 over 2, well, this is not a rational number because this fraction, the numerator, is an irrational number. Okay, so these are rational numbers. So we're talking about rational exponents, and this is a big topic. So for some of you out there that might be taking some sort of math class, you might be saying, hey, Mr. U2 Math Man, where would this be in my math class? Well, you want to look under some topic called rational exponents, which is oftentimes taught with chapters like radical equations or in the power and exponent part of your math course. All right, so let's go ahead and get into it right now because we're going to have to learn a few things about rational exponents and their relationships to radicals. So this little symbol right here in math, most of you might be saying, hey, that's a square root symbol, Mr. U2 Math Man. Indeed it is, but it's also a radical. Okay, so this is this symbol here, this square root symbol, is referred to as a radical because a square root is when we take the square root of a number, right? Like for here, if we take the square root of 4, what is the square root of 4? Well, the square root of 4 is 2. Okay, that is the answer. And I'm going to give you another, observation here, and we'll get into the rational exponent thing in just one second. But the square root of 4 is a positive 2, not a positive and negative 2. Now, a lot of students would say, oh, I know the answer to the square root of 4 is positive and negative 2 because 2 times 2 is 4 and negative 2 times negative 2 is a positive 4, right? The square root is looking for a number such that when you multiply it by itself, we get back to 4. So you might be saying, hey, why isn't it negative 2 as well? Because negative 2 times negative 2 gets us back to a positive 4. Well, that is because, right, this is where I need to kind of slow myself down because I want to give you a nice, clear explanation. But when we take the square roots of numbers, or something like this, the square root of 4, we're only going to write the positive version of the answer. This is something known as the principal square root. This positive and negative business comes into play when you're solving things like quadratic equations, something like x squared is equal to 4. And to solve for x, I'm going to take the square root of both sides. So x is going to be equal to the square root of 4, which is positive and negative 2. These are our two solutions to this quadratic equation. Every quadratic equation has two solutions. So in this case, it's going to be positive and negative. So the positive and negative business comes into play, especially when we're talking about solving polynomial equations. All right, so that's kind of a long explanation. That the square root of 4 is actually just a positive 2, but a lot of students confuse this and they'll write this as positive and negative 2. Right, so it's only positive 2. Okay, now let's go ahead and take a look at what I have written here. So I'm saying that the square root of 4 is equal to 4 to the 1/2 power. Now, when we have a square root, there's actually a little 2 right here. And we're talking about terminology called the radical, the index, and the radicand. I'm not going to go ahead and get into all that in this particular video, but just know that we have a little 2 right here. And the square root of 4 is equal to 4 to the 1/2 power because there is a little 2. So this 2 right here is the denominator. So let's go ahead and take a look at another example. How about the cube root of 4? Okay, so the cube root of 4 is equal to 4 to the 1/3 power. So this little 3 becomes our denominator. If I have the fifth root of 7, what do you think, the equivalent rational exponent will be for this? Well, it will be 7, right, to the 1/5 power. Okay, so again, the square root of 9 is equal to 9 to the 1/2. The cube root of 5 is equal to 5 to the 1/3. All right, so hopefully you kind of see the pattern here. And if you understand this pattern of how we can go from a radical to a rational exponent, and you got to be able to do this, you got to be able to write radicals as rational exponents and vice versa, right? You got to be able to go from rational exponent to a radical and a radical to a rational exponent. Now, the advantage of writing a radical as a rational exponent is that we can use all the properties of powers and exponents, kind of like how I did up here, right? So we're multiplying two powers and the bases are the same. We can simply add the exponents. So that is the advantage of working with rational exponents. All right, so let's go ahead and apply what we learned to our problem. So the first thing we want to do is notice that we have 8 to the 2/3 times 9 to the 1/2. So hopefully right off the bat, you might be saying, hey, Mr. YouTube Math Man, 9 to the 1/2, isn't that the same thing as the square root of 9? Indeed, it is. So remember, you want to be thinking about going from rational exponents to radicals and radicals to rational exponents. All right, so we know that the square root of 9 is 3. So this part of the problem is not too difficult, but this part of the problem will be a little bit more interesting. All right, so let's go and take the next step, which of course is having you quickly subscribe to my YouTube channel. Now, I'm definitely not afraid of this word, and that is help. When I need help, I have no problem asking for it because I have this other word in my vocabulary, and that is a goal. Matter of fact, I have several goals, but for YouTube, my goal is to help as many people as I possibly can, and I can't reach my goal without getting help from you. And the best way to help me achieve my goal is to simply hit that subscribe button and that notification bell. That really does go a long way for the YouTube algorithm. But if you are struggling in mathematics or if you want to maybe reach a particular level in math, well, I would suggest that you frame whatever you want to do in terms of anything in life, but particularly mathematics, frame it as a goal. Okay, if you're taking, let's say, college algebra, or if you're taking algebra 1 or pre-calculus, you should have a goal, and your goal should not be, I just want to pass my class, Mr. YouTube Math Man. That's all I want to do. I just want to get out of this math class. Well, no, well, that's fine, but you should try to get, the best grade possible. Learn as much as you possibly can. So set a specific goal because if you don't do that, then you're just kind of opening yourself up to any kind of random outcome. All right. But in order to achieve your goal, you're going to need help. And for those of you that are math students, make sure you are talking to your teacher. But if you need more help beyond what your teacher can offer, well, then check out my full main math courses. You'll find links to those in the description of this video. Also, I'm posting a ton of content on YouTube, so that's why it's important to hit that notification bell so you can get my latest videos. All right, so let's go ahead and get into the rest of this problem. So here, we know that the square root of 9, okay, is 3. And remember, the square root of 9 is the same thing as 9 to the 1/2. So we have our kind of brain working in terms of looking for rational exponents and thinking about a radical, and then looking at a radical and thinking about a rational exponent. But our original problem had 9 and 1/2. We know that's the square root of 9, and now we understand the principal square roots of the square root of 9 is 3. So now we just have to figure out what 8 to the 2/3 power is equal to, and this is going to bring us to another property of powers and exponents. So remember, here we're talking about a radical, but as soon as we take that radical and we write it or express it as a rational exponent, then we can use all these lovely properties of powers and exponents. So when you study algebra, you study these various properties. Let me go ahead and just write a few here. A to the m times a to the n. So we're multiplying powers with the same base, we are going to add the exponents. When we are dividing powers with the same base, we're going to subtract the exponents, the numerator exponent from the denominator exponent. And then when we're taking a power to another power, we have like a to the m to a to the n. That's equal to a to the m times n. Now, some of you might be saying, hey, Mr. YouTube Math Man, you're going a little crazy here with all these properties. Well, these are things that hopefully you remember. Okay, these are the formal properties, excuse me. But here is an example of a property that we need here. So 2 to the third squared is equal to 2 to the sixth. Okay, now the property here that we are interested in using is a to the m to the n. So we have a power to an outside exponent. We can just multiply that outside exponent to the inside exponent. So 2 to the third is equal to 2 to the 3 times 2, or 2 to the 6. And this makes sense because what does 2 to the third squared means? Well, it means take 2 to the third and multiply it by itself. 2 to the third and 2 to the third means what? Well, that's 3 2's right there. And then we're going to multiply it by another 3 2's. And when we do this big product right here, we end up with 6 2's. So this property makes sense. But the great thing about this particular property is that we can kind of use it to break up a fraction like this. Okay, here we have a to the 2/3, and we can kind of factor out a 2. Now this is a little trick that you can use, but we want to do this because we want to think of this 8 as 8 to the 1/3, not 8 to the 2/3. Okay, we want to think of this as 8 to the 1/3 because 8 to the 1/3 is what? Well, let's go back to what we learned about rational exponents and radicals. So 8 to the 1/3 is the same as the cube root of 8. Now, what does this mean? Well, it means what number times itself gets us back to 8. And hopefully you're saying, hey, Mr. YouTube Math Man, I know the answer. It's 2. Indeed it is. So we know that 8 to the 1/3 is equal to 2. But here we have 8 to the 2/3. But maybe we can rewrite this in such a way where we can end up with 8 to the 1/3. And we can do that if we factor out this 2 up in the numerator. So we can write it this way, 8 to the 1/3, and we'll put the 2 outside here. And this is equivalent to 8 to the 2/3 because we can always distribute that 2 back in using this property right here. All right, so if you understand that, this should be pretty easy to solve. So a to the 2/3 is the same thing as a to the 1/3 squared. So I'm writing it this way just to kind of keep you, engaged with the relationship between rational exponents and radicals. So these two things are the same. So the cube root of 8 is what? Well, we just talked about that. The cube root of 8 is 2, right? So what number times itself 3 times is 8? Well, that is 2. So let's go ahead and figure out the rest of the answer. I'm kind of getting ahead of myself here. So the cube root of 8 is 2. So this right here really is the same thing as 2 squared, right? So the cube root of 8, again, is 2, and we're going to square that. So 2 squared is, of course, 4. And now we are basically done. So 8 to the 2/3, after doing all that work, is 4. Remember, we had 9 to the 1/2, which is the square root of 9, which is 3. So that is going to be 3 on this side of this product. So 4 times 3 is, of course, 12. All right, so again, no calculators here, but you should know how to find the answer to a problem like this using your calculator. So one of the things that you want to do here using your calculator, let's kind of go up here real quick, is most calculators, most modern calculators are actually pretty good with this, but some of the older calculators can be a bit unforgiving. And what I'm talking about is the following. All right, let's take 8 to the 2/3, for example. So in the older calculators, I think you should still do this as a habit. When you want to find the power of something, let's say you have 2 to the 5th power, you're going to use one of these keys like this, an upside down V, which is called a caret, or something like an x to the y. So if you wanted to find 2 to the 5th power, you would type in 2, and then you would hit one of these keys, maybe the caret key, and then 5, and then hit enter, and you would get the value of that power. But in this particular case, we do have a fractional exponent. So what you want to do is take your 8 and then hit your caret key, for example, and then put this rational exponent in parentheses. So put parentheses 2 divided by 3 in parentheses, because if you don't do this, on some of your older calculators, what's going to end up happening is you're going to type in the following 8 to the caret 2 divided by 3. Okay, you're thinking that you're typing in this, but really what you're typing in is, let's think about the order of operations. You're typing in 8 squared divided by 3. Okay, 8 caret 2 means 8 squared, and this means divided by 3. So remember, in the order of operations, you're going to do exponents before division, so you got to be very careful. Okay, so always put your rational exponents in parentheses. Okay, so I know I kind of talked about a lot here. I just can't help myself as a math teacher because I want you to walk away from my video saying, yes, Mr. YouTube Math Man, I totally understand this stuff. Now, if you need additional help with rational exponents, or powers and exponents in general, I would suggest taking a look at like my Algebra 2 course. Okay, so you can find a link to that in the description of this video. Also, I have a ton of additional videos on my YouTube channel about this topic as well. All right, so with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.